Well, welcome back to the OSGi community event. Our next speaker is someone who serves on the OSGi board of directors with me. He's active on Apache projects like Felix and very active in the OSGi Enterprise Expert Group. It's my pleasure to introduce Karsten Ziegler, who's going to be talking to us about service-oriented web development. With that, welcome, Karsten.
Yeah, thank you. It's good to have applause up front, so that's the stage. So welcome to my session. Just to get a feeling about the audience, who here is already developing stuff with OSGi? Oh, most of you. So we are done, right? No, okay, just kidding. So what I will show you are some very, let's say, easy ways of developing OSGi components and services. And there are always a lot of preconceptions about OSGi. It's too slow, it's too complicated, these dynamics kill you, and whatnot. And what I will try in this session is to remove these preconceptions and say it's actually not the case. A funny anecdote is actually I started at the Apache Software Foundation I believe in 2000, which makes me very old, I know, at the Cocoon project at that time. And we had our own component system, our own module system with class loading and so on. So pretty similar to OSGi. Not as good, I would say, but very close. And then in 2004, 2005, I believe, some guy suggested, why are you not using OSGi? And actually, I was in the camp and said, no way, because of some of these reasons. In looking back, I think it was a wrong decision. We should have moved to OSGi back then, because most of the stuff was not really was wrong, except maybe for the tooling. But now we are 10 years later, tooling changed, or we have tooling, and so I think all of these stuff is not true anymore. Oh, okay. So let's start with the easy one. I mean, you're here on the second day already, and you have seen different talks, different sessions. So I guess by now, you know that OSGi is used, let's say, everywhere. On the left-hand side, this is the happy user using all these nice IoT stuff. I didn't have a better picture, sorry for that. And so it goes really from small devices, small applications, up to enterprise applications running in the cloud. So that's true, it's everywhere. So we can forget about that. Let's rather focus on the development side. So how can I develop component services with OSGi? And to do that, I've prepared the greatest web application on my computer, I would say, which is a nice little guessing game. And actually, I will try to demo this. I'm not singing, don't be afraid. I should do that? No. Okay. So this is the web application I'm going to build with OSGi. It's really pretty simple, just to demonstrate the basic concepts. It's a guessing game. You can choose the level from easy to hard. And you can enter your name, so it's me. And start the game. And now you have to guess the number between 1 and 10. And obviously, if you select a different level, the range is from 1 to 50 or 1 to 100. So just to kill some time, I start guessing. It says it's too low. It's too low again. It's still too low, so it might be 10. Yeah. So I won. I'm now in the high score. Can start the game again and try to be better. Okay, so just for the fun of it, this is a game I want to develop using OSGi. So what do I need for this? I need all these building blocks. Sorry. So I need these different things. First of all, I want to develop this in a modular way. So I want to build modules, which are bundles in OSGi. I guess you all know how to do that. I want to have services and components within my bundle that make up my nice game application. So to make up the application, I need some clever software design for that, which took me a lot of time to do that. And this is actually the nice design I came up with. Just, it might not be the best one. So I have an enumeration for the level, easy, medium, hard, and a central game service, game controller service, where you can start a game, you pass in the name of the user, the level, get back a game object, which basically is the status of your current state within the game. The user can make a new guess, the game object is updated, gives back an integer, whether it's too low, too high, or you guess the number right. And you can also find out what the current maximum level, maximum number for a level is. Pretty straightforward. So now we have our interface. We want to write an OSGi component implementing that interface. That's pretty easy to do. You implement your class and use the component annotations. And these annotations are defined by the Declarative Service specification, which is part of the OSGi compendium. So you have a class implementing this interface and annotated with component. Now this annotation looks pretty simple, but it does actually, I would say, a lot of things, because it not only declares your class as a component, it also registers it as the game controller service. So it registers your class with all interfaces you're implementing. So now I can just implement my class. These three methods I have within the interface defined, and I'm more or less done. If I would deploy this to an OSGi framework, I would have a game controller service, which I could use. Now the second interesting thing which you want to do is make this configurable. So you want to configure, let's say, the ranges, the guessing ranges for the different levels. So how do you do that? And now it gets a little bit, let's say, interesting. You could do that by defining an annotation which holds your configuration. So here we have this annotation with 3 configuration values, 1 for each level, and it also contains a default value for each level. Right, so you have a maximum value for the easy level, for the medium level, and the hard level. So this is one part. Now we have defined the configuration options for your component. How can you use such a configuration within your component? First of all, configurations within OSGi are managed by configuration admin, and if you're using declarative services, then this declarative service implementation takes care that the configuration gets passed to your component implementation. So you can just define an activate method, which is a method you annotate with activate, which takes this configuration. And here again, you see the config annotation from the previous slide. So I get passed in a nice object holding my configuration, and I can just store it in my instance and then use it later on. And this makes defining configurations pretty easy, because you can just define them through an annotation with all the default values, but on the other hand, it makes using them pretty easy as well, as you can just directly use this annotation object within your implementation. Like I did here, I can just access the different configurations. And if now a different configuration is stored within configuration admin for my component, I would get these values here and can directly use it. And this even works obviously with more complex configurations, like if you have strings or arrays of strings for your configuration, integers, booleans, whatever you can describe with annotation can be easily used. Okay, so now we have our component implementing the service. We can configure it. So the configuration admin, what's next? We have a web application. So how do we bring it to the web? That's again very easy if you know how, which is, I guess, true for all cases. So you just implement a servlet and register this as a servlet service, again using these annotations. And here again we use a component annotation, declare that this component is registered as a servlet service with some specific configuration properties. And this actually is using a new specification we've been working on in the past years, which is the Http Whiteboard specification. And this basically allows you to register servlets using the whiteboard pattern. So if you have a running implementation of the whiteboard HTTP service, it will pick up these servlets from the service registry, looks at this pattern property, and registers them at that URL. So once you've deployed this code to the OSGi framework, this servlet is available at /game. And this is actually what I used for my sample application. So now we have our game controller interface with the implementation. We have a servlet. How do we connect those two? So how can we use this service within the servlet? And that's pretty easy as well, as you can just use a field within the servlet implementation, which has a type of the interface, and you annotate it with field reference. And now the DS implementation takes care that once your component, your servlet in this case, is started, this reference is filled with the game controller service implementation. And you can just use this controller throughout your code and implement the logic in your servlet. While this annotation looks pretty simple, again, it does take a lot care of all the dynamics that might be going on within your OSGi system. So basically what this annotation in this case means that this is a required service for your implementation, which means as long as there is no game controller, your servlet or this game servlet is not activated, not registered. But as soon as a game controller service is available in the OSGi service registry, the servlet is registered and activated. And obviously the other way around is the same. If the game controller would go away, your servlet would be unregistered and is not available anymore. So this is all hidden in this simple looking annotation, which means all the dynamics for this simple case are taken care of for you, so that you don't have to deal with that within your code. And that's basically all you have to do to implement this simple guessing game application. You define your interfaces for the services, implement them, have your servlet providing the user interface, and you're done. And to do that, you can use, as you might have seen in other talks here, all the tooling which is out there. You can use Ant, Gradle, BND tools, or Maven, which is actually our favorite. So we are using Maven with OSGi for a long time. It works pretty well. And I think it's not that important which tool you're using, because all of them work pretty well. One is better in that area than the other one is better in the other area. Yeah, we have different opinions, I know. But, and you will like my next point, Peter. But I think the most important point is when you use this tooling, that you're developing your API, following semantic versioning, and using the baselining feature from BND. And this brings me to another demo, just to show you what is possible if you're using Maven. If you have to use Maven. Let's put it that way. I'm getting it. So this is basically a simple Maven project holding all my code. I showed you the basic architecture and implementation and so on, so I don't go into that again. But the interesting thing is I've installed a plugin for Eclipse, which we developed in the Apache Sling project, which basically connects to a running OSGi server. And if I now do some changes in my code, let's see, OSGi, guessing game, hit save, go back to my website, and the updated bundle is already running here. So basically, whenever you build your project in Eclipse, and I've turned on automatic build for my project, it simply deploys a new version of your bundle to the OSGi framework, and you can immediately test it, which I think is pretty nice. And this only works with Maven. No, I'm just kidding. Okay. So I think this is pretty nice and gives you a very fast turnaround, right? I mean, you just change your code, a new bundle version is updated to the OSGi framework. You can directly test it. And especially as we are deploying a new version of the bundle on every build, you can do all kinds of changes within your code. So it's not just code replacement, it's really a new version of the bundle. If you're adding a new interface, adding a new component, using different annotations, this all works perfectly. Yeah. So, we have our guessing game running, and we look at all these preconceptions I put up before. And as I hopefully could prove in this very short time, is that not suitable for the enterprise is simply wrong, right? It just works everywhere, it runs everywhere. Too complicated? I don't think so. It was really a minimum amount of code you had to write. You just use the annotations and you're done. What I wrote were POJOs, so that's okay as well. No dependency injection. We have this field reference, which is pretty easy to use. So that's all not the case either. Dynamics, you can manage them easily, again with this field reference, and the DS implementation takes care of it. So what's left is no tooling, which is wrong. We have Maven, we have BND tools, and other stuff. And too slow, well, I mean, it's always hard to prove that it's not slow. But I mean, what you can see from OSGi, it's not using any proxies or anything, it's just plain direct Java objects method calls. So I wouldn't call this slow either. Which means we are done. But of course, I want to show you a little bit more than I did in this 20 minutes or so. So just to show what I've used in this sample application is, I used more or less let's say three specifications from OSGi. The most important are the declarative services, which allows you to develop these components and services. And especially with two additions we did in the past 2 years. These are the different RFCs mentioned here. And they will be part of the R6 release, which will be released, again, I think beginning next year, right? And more or less, these specifications are already implemented in the open source, so you can already start using them. The second specification is a new one, the Http Whiteboard Service specification, which will be, again, part of R6, so available pretty soon. Configuration admin is very old, works without any problems, so you can directly use that. And there's also the metatype service, which I haven't mentioned yet, because I will show you in a few minutes why I think this is important. So if you're using these specifications together with the tooling, developing web applications based on OSGi is really very easy, I think. And the nice thing is you get open source implementations for all this stuff from the Apache Felix project. So once you have written your application, what about the management of it? There's one good answer, I think, which you might have seen in other talks as well already. That's the Apache Felix Web Console that allows you to manage your application. And now I'm doing this tricky microphone shuffle again. For the last time, I promise. Okay, so this is the web console. I'm not going into all the glory details of it, but it allows you basically to see the state of your OSGi application, the bundles you have deployed, the services that are registered, the configurations, and all this nice stuff. And as we have developed this game controller, which is configurable with these different levels, I can go to the configuration tab on the web console, and I will find down here the configuration for my game controller service. So I can configure here directly the 3 different values for the 3 levels. And as you can see, I have some nice labels and descriptions for these different things. But if you remember the code I've showed before, it didn't had anything of these labels, names, and so on in it. So how does it work? And this brings me back to the presentation. So we already had this configuration annotation, which had these three fields for the different values. If you want to add metatype information, which is then, for example, used in the web console, so you have a nice form and nice descriptions of your configuration, you can just add annotations to your configuration annotation. So first of all, you add an object class definition annotation, which marks this thing as something that is described by the metatype service. You give it the label or the name, and it's here, and a description. And then you can add a name and a description to each field that is configurable. And this makes a nice metatype description for your configuration, which then is picked up in the web console. The only thing in addition you have to do is to connect this description to your component. And you just do this by adding this designate annotation to your component and specify which metatype description is used for your component. So it's again the config class in this example. And this gives you this nice description. That's all you have to do. Right. So again, that's fairly easy. If you have a large application consisting of a lot of bundles, you sooner or later end up with using third-party stuff, and you don't really have control whether these people are using declarative services or anything else. So some of them might use in their bundles declarative services, others might use Blueprint because they have a Spring background or whatever. Others might be very brave, let's put it, and use the framework API directly to register services and do their stuff, or they use some of the other existing component frameworks like Apache or Dependency Manager and what else is out there. And the nice thing is all these things work together because they are connected through the global service registry. So all of them register their services in the service registry, and no matter which component framework is used to develop those components, they can interact easily and it all works fine. So that's very nice. When it comes to services, there are different types of services, or different scopes, how we call it. You can register your service as a singleton, so it's a global instance for all clients using your service. You can make this on a bundle level, so each bundle using your service gets a different instance. Or this is a new scope, the prototype scope, so each client using your service gets its own instance. And when you develop your component, you can define what scope your component has. So this is the configuration of the component annotation you put in your class. And why do I mention this? If you're dealing with servlets following the Http Whiteboard Service specification, then it makes sense to declare them as prototypes. Just to mention this here. I think the next talk in this room is about the Http Whiteboard Service by Ray, sitting in the back, and maybe you're covering this topic as well. So we don't repeat the same stuff here. Just to mention it, that this exists. I think what is more important for the remainder of this talk are these things. First of all, if you're developing a service with DS and no one else is using the service, and it's sad, of course, but then the nice thing is it's really lazy instantiated. So if no one using your service, it never gets really activated or instantiated. It doesn't cost you any memory or whatever. Then the other two things that are interesting are different kinds of references you might have to other services. So in the example so far, we had a required reference to the game controller, and the servlet was only active when a game controller was available. Hello. And that's the simplest type of reference you can have. But there might be services that are optional for your implementation. Like, for example, in my case, I have a statistics service, but my game runs without the statistics service. So if the database is down where all the statistics are stored, my servlet still runs without any problems. So I can just mark this reference as dynamic and optional, and my component is activated regardless if this statistics service is available or not. If it's available, the field contains the reference to that service. If not, it's null, so I can deal with that within my code. Then these are the simple references for just referencing a single service. But what is also interesting is if there are multiple implementations for your service. So for example, we have these 3 levels, easy, medium, hard. You might have a different high score service registered for each level. So you want to get all 3 services. And you can just do that by having a field containing a list of high score services, marking this again with a field reference saying it's a multiple, reference. And then the DS implementation fills this field with a list of available services. And whenever this set of available services changes, this field will be set with a new list containing the new set. And the other thing, if you want to have more control and you want to provide your own implementation, you could instantiate it with a concurrent set, a skip list set. And in that case, DS will call add and remove whenever a new high score service arrives or is going away, which gives you a little bit more more detailed way of handling that. And the final thing I want to show you is a very interesting thing, actually, I think, which is reconfiguration. Now, if you're just doing this one, you have this activate method which gets the configuration and is marked as the activate method. Whenever the configuration is changed, it basically means that your service is stopped, unregistered, activated with a new configuration, and registered again. Which is not that problematic with just one service. But for example, remember that this service is referenced by the servlet we're using, which in that case means this service goes down, the servlet goes down. And of course, there can be a lot of dependencies between your services. So basically, reconfiguring one service might mean that your whole system goes down and goes back up with a new configuration, which is not a problem at all, by itself, because it works without any problems. But it also means there's some downtime, right? If the servlet is not available, people can't use my great guessing application. So they will be really frustrated and go somewhere else, which I don't want. So you can avoid this by adding a second annotation, the modified annotation, and this means your component stays active but gets just called with a new configuration. So everything stays up and running, or services stay up and running. They just get the new configuration. You do whatever you have to do with this new configuration, with the new implementation, and that's it. Just to mention this. Right. And this basically brings me to the end of my talk. So if you want to develop web applications, the way to do this today with OSGi is to use the Http Whiteboard Service. Again, the next session is exactly about that, to get more detail about this. It allows you to register servlets, listeners, and so on. Everything which you know from the servlet API through a whiteboard pattern. And for developing components, at least my opinion is that Declarative Services is the best and easiest way to do that. It's really easy to use with all these annotations. Most of the dynamics is taken care of you, so you don't have to deal with that yourself. There's very good tooling out there you can directly use, and of course there are open source implementations. And this allows you really to build nice applications for these small IoT things up to large applications running the cloud. And that's the end of my talk.